cylindrical shells. And this is, you're finding the volumes of the exact same object as we did in the previous section, but we're doing it in a slightly different way. It's by cylindrical shells. So it's solids of revolution. So you're revolving about a region about an axis, a revolution, and then, but you're taking the cylindrical shells instead of the cross sections. And so the volume of a cylindrical shell, so this is a cylindrical, this is what we're looking at. We're looking at a cylinder like this, and the volume is equal to and we're just looking at the volume of the outside part, not the top or the bottom. So the outside part, it's the circumference times the height. And the circumference is 2 pi r, and the height is h. Okay, and now you're multiplying it by dr. That's like a thickness there. So, and that gives you a volume. Okay, so that's what we're looking at right there. Okay, so you have two formulas depending on which way you're revolving. So this one is if you're revolving in the axis. So this is if you're revolving about a vertical axis. Okay, so if you take like, let's suppose that we take a region like this and we revolve it about the y-axis, okay? Or it could revolve about it something else. So what's going to happen is each point is going to get revolved around. And if you take like a value of x and you have this line right here, then this gets revolved around and you get this cylinder here. Okay, so any vertical line segment gets revolved around into a cylinder. And so what you would do is you would integrate here from A to B of this, and probably you would want to have straight lines as here, and then an f, and then some function here, another function there. So I guess this drawing really doesn't look that great, but oh well. And then this one right here is where you're revolving about a horizontal axis. Okay, so you're revolving this way. So if you take a line segment here and you revolve that line segment around, then you're going to get a cylindrical shell. Okay, you're going to get a cylinder. And so the surface area of that cylinder is 2 pi r h, and the radius, and then dr is the thickness of that cylinder, so it's a shell. Okay, and so here you'd go from C to D to cover, if this is the region that you're integrating across, that you're revolving, then you want to go from C to D on the region. Okay. So let's get into some exercises, because this is probably not very clear what I'm saying so far. So let's do some examples. Okay, for the first one, we're going to, that S is the region, is a solid obtained by rotating this region here about the y-axis. So it's being rotated this way about this axis. Okay, and this is y equals, it's ax times x minus b squared. But a is 7 and b is 2. So this is going to be 7x times x minus 2. Okay, so this a is 7 and then the b is 2. So squared, like that. Okay, so it's going to be like that. And this is going to intersect the x-axis in two places, where x is 0, the whole thing's 0, and where x is 2, the whole thing is 0. Okay, or where x is b, so b is 2. So it crosses in those two spots right there. Okay, now it's actually going to be this one right here, where it crosses at 0 and 2. This one also crosses in 0 and 2, but this is being revolved about the x-axis. And it says revolve it about the y-axis. Okay, so that means that's wrong. That means that this one is the correct one, because it's being revolved around the y-axis. This one right here comes all the way out to 7, so that's why that one's wrong. And then again, this one's wrong, also wrong in both those. Okay, so this is what it looks like. So, like if you change the scale a bit, then you get something more like this. Okay, so what happens is you have these cylindrical shells. This is just a typical one. You could draw another one over here. You could draw another one over here, which would look like this. And that would be revolved around like that. Okay, so that would be another cylindrical shell revolved around. But each value of x gives you a cylindrical shell. Okay, and so the formula, remember, was you integrating from a to b of 2 pi, and then r of x, h of x, dx. Okay, so 2 pi rh is the area, surface area of the cylindrical shell. Dx sort of stands for the thickness. So the thickness of the shell. See how it's got a little bit of thickness? And that's what it gives it volume. And that thickness is thought of to be dx. Okay. So we plug everything in. This A and the B is different from that A and B. But yeah. So we're going from 0 to 2. 0 to 2 represents all of the cylindrical shells. You don't need to come back here, because when you're choosing a value x, it's including the whole thing all the way around, which includes this part here. So you just need to go from 0 to 2. Okay, now the radius, that is going to be this distance here from 0 to x. So that's just going to be x. Okay, and h of x is the height. The height is going to be whatever the value is on the curve. So it's going to be here. It's going to be this. 7x times x minus 2 squared is going to be the height. Okay, so that's what we're looking at. Okay, so we have 2 pi times 7. That's going to be 14 pi. And that can come out because there's no x's in it. You have an x times x. That's x squared. I'll go ahead and expand this out so that we can integrate it easier. Distribute the x squareds. And now we integrate. That's x to the 5th over 5 minus, this is just x to the 4th. When you take your derivative here, you have a 4 coming down, which is right there. And then this is 4x cubed over 3. And now it's going evaluated from 0 to 2. Okay, plugging a 2 into here, 2 to the 5th is 32. Here it's 2 to the 4th, that's 16. Here it's 2 cubed is 8. 8 times 4 is 32. And then when you plug zeros in, then it's all 0. So you get that. Okay, now I plugged all this into the calculator and then multiplied by 14, and then I got the fraction, and that's 224 pi over 15 as the final answer. Okay, any questions or comments about that? Okay, let's move on to the next exercise. More examples. Okay, so negative x squared, y equals 0, x equals 0. So it's the region in the first quadrant, but that's being revolved about the y-axis, about the y-axis. Okay. It's also bounded by x equals 1. So it's going to be this first answer, because here, okay, so here is x equals 1. There's the curve x equals 1. This part right here is y equals 13 e to the negative x squared. So when x is 0, this is just, it's up at 13. Okay, so that's why it's at 13 there. It doesn't matter. That doesn't figure into the calculations, but that's 13. And then y equals 0 and x equals 0. So y equals 0 is right here, and x equals 0 is right here. So it's this region here that's being revolved around the y-axis. Y-axis. There's a y-axis right there. Okay, let's see here. This one, so this is the wrong region. That's the wrong region. This one's the correct region, but they're doing it with disks. Okay, so you could try doing it with disks, but the problem is, there's a couple problems. One of them is that this formula right here doesn't do too well for disks, because to find the radius, you're going to have to solve this for x. So you'll have some weird expression with logarithms, and logarithms are not that fun to integrate. And then the second problem is that down here, which is not that big of a problem, because this makes it really easy. From 0 up to, it looks like about, well, where these two intersect, where these have to set this equal to 1 to figure that out. Where from 0 up until where these two intersect, then it's going to be, the disks are going to all have radius 1. And so that's just going to be like one big cylinder right there. And then from where these meet on up to here, it's a different formula. So it's going to be basically two integrals that you'd have to do. But you're not supposed to do it that way anyway, so cylindrical shells. Okay, so you remember that the formula is the integral from a to b of 2 pi r of x h of x. That's when we're revolving about a vertical line. Then you're in x's. Okay, so now a, it's going to go from 0 to 1, from 0 to 1, or a and b. Now r of x, that's going to be this distance from here to here. That's the radius of the cylinder. And that distance is, because this point right here is considered to be x. So this distance here is x. And like I said, it's not always going to be x, but in this case it is. And in a lot of cases it is. Okay, then h of x is going to be this height right here, from the ground, from the x-axis all the way up to there, and that's 13 e to the negative x squared, like that. Okay, great. So now let's go ahead and calculate this. The 13 and the 2 pi, that's 26 pi. I'll pull that all the way out to the front. And we're left with x e to the negative x squared dx. Okay. From 0 to 1. Okay, now you can use a u substitution, and so here's what you can do. You can u be negative x squared would be good, because that's the inner function right here. So then du would be negative 2x dx. So you can do it that way, but what I like to do at this point, what I like to do is just guess what the integral is. Okay, so that's basically, and taking integrals is just the guessing, really. If you have a good idea, like I'm thinking the derivative, the integral would be something like this, e to the negative x squared. Because when I take the derivative of this, I get itself, which is right there. I also get a negative 2x. Okay, when I take this derivative, I get a negative 2x coming out. There's an x right there, but I don't have a negative 2. But that's no big deal. I just divide by negative 2. And there we go. Okay. So dividing by negative 2. So now when I take the derivative, all this is just constants. When I take the derivative, then I'm going to get e to the negative x squared, which is right there, times the derivative of this part, which is negative 2x. So I'll have a negative 2x. There's the x, and negative 2 gets canceled with that negative 2. Okay, and of course, that's evaluated from 0 to 1. And also, let me interact these two. This is 26 divided by 2 is 13, so that's negative 13 pi e to the negative x squared, evaluated from 0 to 1. Okay, so now I'm going to put in the upper limit first. That's e to the negative 1. 1 squared is 1, minus the lower limit, e to the 0. E to the 0 is 1, and then this negative also interacts here. That's e minus 1. The negative can distribute in, and I get 13 pi times 1 minus e. Okay, so that should be the answer right there. Wait. This is e to the negative 1. So this is, I'm sorry, 1 over e. Okay, another thing that I'm just noticing that I forgot to mention on number 1, let's go back here really quickly. So it's asking for the circumference. Okay, so the circumference is all of this. Let me do it in a different color. So that's 2 pi x is the circumference. And it's also asking for the height, h of x. And h of x is all this. It's 7x times x minus 2 squared. Okay, great. Let's go on to number 3. Use the method of cylindrical shells to find the volume V of the solid retained by rotating the region bounded by the curves x equals 4 plus 1 minus 6 squared and x equals 20 about the x-axis. Okay, now this curve right here, if it was y equals 4 plus x minus 6 squared, if it was like that, then, well, the vertex would be 4, 6, and it would just open up like that, right? But these are reversed, so what we actually have then is wait, what am I doing? The vertex would be 6, 4, I'm sorry. I was saying a bunch of stuff without thinking. The vertex would be 6, 4, because x being 6 would zero that out, and then y is 4. Okay, so it would be something like that, right? But because it's like this instead of y equals 4 plus x, it's x equals 4 plus that. And that's y there instead of an x. Okay, so that means that the vertex is going to be, that means it's opens right, and the vertex is going to be 4, 6. Okay, because when y is 6, then that zeroes out, and so that and x is 4. So 4, 6. So it looks like this is the correct vertex. This does look like it's at 4, 6. This also looks good right here. These ones are. Wait a second. This is revolving about the y-axis. We want to revolve about the x-axis. So that means that this one and this one are out, and these two are okay. These two are specifying the correct region, but then right here it's saying to use cylindrical shells, and that's not a cylindrical shell, and that one is. Okay, so that means this is going to be the answer. Okay, so it's this region right here that's being revolved, and so it's kind of confusing because whoa, what's this doing down here? This is just the projection. So it's as if we revolved this region. So it's just this region. It's not this region down here, but this region is being revolved about the x-axis. And so if we revolve that, we'll get some kind of circular object. If you take a cross section of that, then this region down here will be part of that cross section. Okay, so now cylindrical shells. Let's go ahead and do that. So that's going to be, now this time, what's happening is you're going to be integrating in the y direction. You're going to be integrating in this direction here. So what we need to do, before we do that, let me do something. What we need to do first is figure out where these intersect right here. We need to figure out what those points are. And this curve right here is x equals 20 right here. It's 20, x equals 20, which just come from that. Okay, so I'm going to take that, and I'm going to set it equal to 20. So take this expression, x equals that, and x equals 20, so I set that equal to 20. Okay, so that gives me, by subtracting 4 from both sides, I get this. Taking square roots, I get plus or minus 4. So we'll do negative first, then we'll put the plus first, and then we'll put the plus there. Okay, so this is equal to negative 4. Then we add 6 to both sides, and you get y equals 2. Add 6 to both sides here, you get y equals 10. So this is actually 2, and this is actually 10. Okay, so we're going to be integrating from 2 up to 10. That's our limits of integration. So the integral from 2 to 10 of 2 pi, and then we have r of x. No, it's going to be r of y now because we're integrating in the y direction. And then h of y. Okay, the radius is going to be from the x-axis up to this point here, which is y. So that's going to be y. And the height is going to be from the curve to 20. So the height is going to be 20 minus this value here. Like that. Okay, so once again, this height from here to here, this is the right endpoint, which is 20 minus the left endpoint, which is this, okay? So that's what our height is going to be. It's all that. Okay, let's continue over here. So you're integrating from 2 to 10, 2 pi y. Okay, and this is 20 minus 4. So I'm distributing that minus into there. This one, if we expand all this out, we get, what is it, y squared minus 12y plus 36. Okay, so if we distribute the negative sign in, then we have a minus 4. We have a minus this, minus y squared, minus a negative 12y, so that's going to be plus 12y, and then minus 36. So that becomes all of that. Okay, so 20 minus 36 is negative, let me see here, negative 16. Wait, negative 20. 20 minus, okay, so 20 minus 4 is 16. 16 minus 36 is negative 20. Okay, that accounts for all that. Then we have minus y squared plus 12y. Okay, I'm going to distribute this y in before we can integrate. So you got negative 20y minus y cubed plus 12y squared. Okay, now I'm going to integrate. Okay, so integrating 20y, we get negative 10y squared. Because when you take the derivative here, you have a 2 coming down, so it's got in the derivative is negative 20y. And then this one is y to the 4th over 4. And then this one is, when you integrate that, that's going to be 4y cubed. And that goes from 2 to 10. Okay, now I'm going to plug in a 10. This is plugging a 10 here gives you 10 squared, which is 100. 100 times 10 is 1,000, so negative 1,000. Here it's minus let's see, we plug a 10 in here, you get 10,000 over 4. And then plugging a 10 here, you get 4,000. Now plugging a 2 in, we get negative 10 times 4, that's negative 40. Plugging a 2 into here, you get 16 over 4. Which is 4. And plugging a 2 into here, you get 8 times 4, which is 32. Very frustrating. Okay, so I calculated all this out with the calculator and got 1,024 pi. Now, including distributing the negative signs in and everything. Okay, so that's number 3. That was kind of, it kind of got tedious at the end because we don't have like, so a lot of times we'll just have a 0 down here and the 0 zeros everything out, but we didn't have it this time, so that was unfortunate. Okay, so let's look at number 4. Use the method of So here they're not giving you a drawing or anything. They're just saying, use the method of cylindrical shells to do this. Okay, so you're going to revolve these curves about the axis y equals 2. Okay, so let's draw a picture of this. Okay, so the first one, x equals 7y squared. So that's going to be a parabola that opens to the right. The vertex is at the origin. It's going to open to the right like this. Okay, now x equals 7. That's going to be right here. That's a vertical line right here. X equals 7. And we can figure out where these intersect. If you set, because this is x equals 7y squared, this is x equals 7. So set 7y squared equal to 7. And you have y is plus or minus 1. So this is 1, that's negative 1. So this intersects at the point 7, comma 1, and this is 7, comma negative 1. Okay, so now we also have this curve right here. And so that's y greater than or equal to 0. That means that we're going to throw this part out. And I think I copied this down wrong. This shouldn't be there. Yeah, this shouldn't be there. Ignore that part. Okay, that's not in the homework. Okay, so here now is the region right there. That's the region. And we're going to evolve it about the axis y equals 2. So here's 1. There's 1. Here's 2. So, and here's 3. Okay, just for reference. So this one, if you revolve this around so this region right here is being revolved around this axis here, y equals 2. So that means at this point, we'll get revolved around and we'll pass through 4. Okay, that'll pass through 4. This point here will get revolved around and it'll pass through 3, like that. Of course, this point here will go to the 4. So we're going to get something like this. If we revolve it around and then we take a cross section, slicing along the XY plane, we get this region and that region. But in reality, we're revolving this around. So what you want to do is you want to integrate from 0 to 1. Let that be y right there. Here we need the r of y and we need h of y. Okay, so let's figure out what those are. So first of all, r of y. That's going to be, so like if this is y right here, then we're taking this line right here and we're revolving that line around the x-axis, around the axis y equals 2. I'm sorry. Okay, and so this is the cylinder that we're looking at, and we need to figure out what the volume of that cylinder is. So the radius, first of all, the radius is going to be this distance here, from the middle of the cylinder to here. That's the radius. which is going to be 2 minus y. Okay, so that becomes 2 minus y. So this distance is 2 minus y, because it's the upper larger value minus the smaller value, 2 minus y. That's our radius. Now our height is going to be this distance here. So that's going to be our left point, which is at 7, minus our right point, which is 7y squared. Okay, so this curve is x equals 7y squared. So that's our x value is 7y squared. Here x is 7. So 7 minus 7x squared will be the h. Okay. So now we need to multiply everything out, except maybe not the 2 pi. Maybe the 2 pi can just go all the way out to let's just put the 2 pi out all the way out to here, actually. Okay, let's multiply these together. Okay, so 2 times 7, the first 2 times 7, that's 14. The outside one, so 2 times negative 7y, that's going to be minus 14y squared. The inner ones, so negative 7 times, no, your negative y times 7, that's negative 7y. And then the last one, so negative y times negative 7y squared, that's going to be plus 7y cubed. Okay, now it's time for integration. Integrating 14 gives you 14y. Integrating this one gives you y cubed over 3. Integrating this one gives you y squared over 2. And then this one is going to be y, or 7y to the 4th over 4. And that's evaluated from 0 to 1. Yeah, I like this lower limit. That's my favorite limit of the two, because, you know, it's easier to deal with. Okay, so we put in the upper limit, we put a 1 in, so it's going to be 14 minus 14 thirds minus 7 halves plus 7 fourths. And then we subtract and put the lower limit, and everything zeroes out with the lower limit, so that's good. So it's just going to be all of this right here, and yeah, this right here. And I did run it on a calculator, and I got 91.6 pi. Okay, great. Any questions about any of this so far? Okay, let's go on to the final, to the fifth and final problem. Here it's kind of switched around a little bit. What they want you to do, they give you an integral. The integral represents the volume of a solid. Describe the solid. So here we have an integral, and we're trying to describe a solid. And the 2 pi is a good indication, and plus we're in the section where we're doing cylindrical stuff. So you want to try to compare with this from A to B, 2 pi r of x, no, r of y, because everything's in y's. Everything's in y's. So you want to try to compare with this and try to figure out what's the r, what's the h, and then work from there. Okay, so I guess the easiest way to split this up into a product is have one of the terms be 1 over y squared and the other one be y plus 8. So maybe, so one possibility could be that r of y is 1 over y squared. That's weird. And then h of y could be y plus 8. Maybe. Okay, so let's look and see what happens when we look at each of these. So we look at the first one. Let's consider the first one. Okay, so the region between 0 and 1 over y squared, y goes from 1 to 4. Oh, that's a good indication too, that it's going from 1 to 4. About the line y equals -8. Okay, so what would this look like? X is between 0 and 1 over y squared. Let's see, x equals 1 over y squared. What would that look like? Let's see, when y is 1, x would be also 1. When y is 4, x would be 1 over 16. Okay, so when x is 1, y would also be 1. And when x is 1/16, y would be, whoa, so 1/16 would be right there. Y would be up at 4. Okay, so it's gonna be like that, and x is between 0 and that. So it's this region. So that could be this region right here. We revolve that around the line y equals -8. Oh, -8. So that would be way down here. So you're revolving this thing, this region right here, getting revolved around like that. If that was the case, then the radius Well, if that's the case, the radius would be that one and the height would be that one. Okay, so the height would be this one right here. And the radius would be all the way from here to -8. So if this is -8's down here, then the radius would be all the way from here to -8. So that would be y plus 8. Yeah, so that one would work. This one actually works. The first one actually works. Okay, so now let's take a look at some of these other ones. Here you're revolving this one about the line y equals 0. If you're going about this one, then r of y would be just y. And so that doesn't really fit in anywhere here. And you never get the y squared, so that's going to be wrong. This one, let's see, the third one. Yeah, here the radius would be y plus 8, or could be. Yeah, that's what it would be. Right here, 2 pi over y squared. Oh, the problem is the 2 pi. So this first and the first and the third one are the same, except for there's this 2 pi here, and that would mess things up because the 2 pi is built into the formula. This one would give you an extra. It would be 4 pi squared if it was this one. Okay, and let's see. Again, this one would be, the fourth one would be, you would have problems with this one, just like you had with the second one. And let's see, the fifth one, so that couldn't be the fourth one. The fifth one, it would be integrated from 1 to 2. This is the problem right here. And here we're integrating to 4.